So what is SwiftyMocky? SwiftyMocky is an amazing open source library that allows you to auto-generate mocks for your dependencies in your unit tests. And it is powered by Sourcery, which is the most famous code generation tool available. So thank you, Christoph. We should give him a round of applause because of his amazing. So what are the features that make SwiftyMocky so useful for your team? The first thing, on a mock created by SwiftyMocky, you can set return values for your variables and your functions. You can perform completions to test your asynchronous code. On the validation side, you can verify which parameters are used in your function invocations to validate their correctness. And finally, it's easily integratable with your favorite dependency managers, so CocoaPods, Swift Package Manager, or Carthage. So let's now have a look at how you integrate SwiftyMocky in your project.
Hello and good afternoon. It's a bit of a thrilling moment today as it's our first time on stage, so thank you for being here with us. Actually, last year was my first time at the Swift Hero conference, and we were just in the other side of the room with my colleagues, Davide, Riccardo, and Matteo. They are here in the first row just supporting us. And we were just making fun, some jokes, and we were saying why we are not, we cannot be a speakers, or why we cannot share our experience with others. So here we are, we just kind of made it. So let's probably wait until the end of the presentation to check if we can do it. But yeah, thanks for being here. Before to start, we would like to ask some serious questions. So please feel free to raise your hand, don't be shy. And the first one that we are curious about is who is attending the Swift Hero for the first time? Oh my God, a lot of newbie. I thought that we were just more expert Swift Hero. Okay, nice. And who write tests in their daily work? If you are forced to, doesn't count. So yeah, so okay, nice. And who think their job will be replaced by ChatGPT? Davide, you are losing. Davide proposed these questions, so we had kind of discussion on that. But thank you for participating. So now something about me. I'm Sara, as you already heard. I currently live in Sicily. I enjoy the sun and the food. I really love to do hiking. I used to do it every Sunday, and it's where I feel most at peace and alive. Actually, I have a kind of complicated relationship with mountain. I really like enjoying skiing, but I'm still falling down from the mountain sometimes today. And something that is not like a secret is my love affair with the relationship with wine, especially if I'm sharing it with friends. I think that at that time, no CI errors, Slack messages, or I don't know, weird bugs can defeat me, so you know where to find after work. And at last, I'm an iOS engineer at Conto. I started my career in the iOS world about 4 years ago, and since then has been super challenging. And now I will have some fun, as I will present Davide as well. He's a musician, he's really into metal music, and lately spending tons of money in guitar, cymbals, and so on. He said that he's an embarrassing surfer, but I don't trust him. I'm pretty sure that he can stay on the board for more than 3 seconds than me. And I didn't mention that he come from Padua, so he kind of have a moral and geographical duty to drink Aperol Spritz after work. So, and at the end, he's a senior iOS engineer at Conto, and he's an incredible colleague. Thanks for all the patience in the last few weeks. So, as I said before, we joined Conto pretty much less than 2 years ago. And who is Conto? Conto is a business financial solution, was launched in 2017 by Alex and Steve, now operates in 4 different markets. French, Germany, Italy, and Spain. And actually now we are more than 1,400 people. The mobile team is more than 100 developers, and pretty much the 50% are iOS developers. Huge milestone. Last year we integrated Penta in our family, and just a few weeks ago we kind of onboarded Regate as well. So now that the presentation been made, let's dig into our key points of today's presentation. Today we are gonna talk about our testing journey, how to sleep well as developer, especially the day before the release, and about SwiftyMocky, how the framework, how we're using it, and at the end some data, performance, how some implementation that we made, and how to go beyond SwiftyMocky with this open source library. So let's start. So I'm pretty sure that as a developer, we have two kind of possibility when we are in the instant before hitting the pillow of the night. The first one is that actually you find the solution of your bug. You start to picturing everything on your mind and start to implement, and you know what to do the next day. And the second option, because we have a second option, is okay, I will kind to wonder if am I using the correct user permission, or did I refresh the UI, or am I using the correct date formatter? And I think that this was the kind of feeling that back in 2017, our two developers that were working at Conto had. They were kind of racing against time to ship core functionality, and they were trying to scale the business. And moreover, we were trying to attract entrepreneurs to join our journey. But with great growth comes also great responsibility, and the responsibility for us was just to make sure that we were delivering an app that was free from any bugs or glitches that can turn our user away. So what did we do? We just introduced unit tests in our code base using XCTests. It's a hyper framework, you already know it. But as you know, while we were changing our app architecture and also our dependency structure, we realized that this was coming with some limitation. The limitation that we found, it was that even if Xcode was supporting UI testing, there were some other party library that were more flexible, especially when you need to test a complex UI scenario. We found that there was no built-in support for mocking and stubbing, so it was hard to isolate units, especially when you start to dealing with this external dependency. And we were forced to add some code to our code base just for testing multiple scenarios. And at the end, we were missing some advanced assertion. So true, false, nil were not enough anymore. So at that point, did we were getting some good sleep at night, or did we start to counting bugs instead of shit, like him? Not exactly, actually. Just because the context was a bit changing. Now, we were not anymore 2, but 10 iOS developer. We were reaching the goal of having more than 1,000 customers, and now our priority was to ship with high quality and confidence. So what did we do at this point? We just decided to increase our code coverage. So we changed the coverage from less than 20% back in 2017 to now we reached the goal to have a code coverage of 80%. At this point, that the app was having a shape with a clean dependency, we needed to make sure that this dependency were well tested. So we needed to create realistic dependency. This means that we needed our test environment needs to mirror as much as possible the real world. We needed to verify specific interaction. This means that the call that our units were performing were just calling the correct dependency, and they were communicating as expected. And also that by mocking and stubbing our response of our dependency, we can predict how our units were kind of behaving under various scenarios. Of course, all this was like done manually, and it was coming with a bit of a headache, and this was like leading to some repetitive task because we needed to create some mocked object, some code duplication that we need to support, and frustration because at this moment the developer creativity needs to kind of doing not creative task. So at this time that we kind of reach to the point of integrate SwiftyMocky. So now I will call Davide for like a more insight on the framework.
Thank you, Sara. So what is SwiftyMocky? SwiftyMocky is an amazing open source library that allows you to auto-generate mocks for your dependencies in your unit tests. And it is powered by Sourcery, which is the most famous code generation tool available. So thank you, Christoph. We should give him a round of applause because of his amazing contribution. So what are the features that make SwiftyMocky so useful for your team? The first thing, on a mock created by SwiftyMocky, you can set return values for your variables and your functions. And especially in the case of functions, you can set different return values depending on the input that you give. You can perform completions to test your asynchronous code. This if you haven't migrated to Swift concurrency yet, of course. On the validation side, you can verify which parameters are used in your function invocations to validate their correctness. And finally, it's easily integratable with your favorite dependency manager, so CocoaPods, Swift Package Manager, or Carthage. So let's now have a look at how you integrate SwiftyMocky in your project. It's really simple. There are 3 steps to this process. First, we start by the creation of a mock file. The mock file is where the Sourcery configuration lies, and this is the first step of our process. The second step is the protocol annotation, so you actually need to specify which protocols you want to mock for your unit test. And finally, the mock generation itself, so you can go ahead and trigger the code auto-generation so you don't have it to do manually. So let's have a look one step at a time. We start by the creation of the mock file. The mock file is a file that resides in your root folder. And the first line is the Sourcery command, so you specify the executable of Sourcery to use in your code generation. In this case, we're using the one in our pod folder. You need to specify then the Sourcery template. The template is the blueprint from which all of your mocks will be generated, and mock.swifttemplate is a file that you can find directly in the GitHub repo of SwiftyMocky. And on the module-specific configuration, you need to specify the sources to scan to look for protocols to mock. You need to specify the output that in this case is a mock.generated file, and we'll talk deeply about this specific file. And for compiling your mocks, you need to specify which target they belong to and the testable or non-testable imports in your mock.generated file. The second step is the protocol annotation, so we specify which protocols to mock. We can do this in 3 ways. The first is with a Sourcery annotation, which is a simple comment on top of the protocol that you want to mock. The second way is with protocol inheritance, so you just create an empty automockable protocol, and you can inherit from that protocol in your protocol to be mocked. And finally, the third way is protocol composition. So SwiftyMocky supports type aliases, so you can create mocks for the composition of your protocols. And finally, and here's where the magic happens, just open your terminal, you call SwiftyMocky generate, and in a second, you'll have your Mock.generated file containing all of your mocks ready to be used in your unit tests. So let's now have a look at a code example to understand how to use SwiftyMocky easily. We'll start from what we call a puppy presenter, which is a simple component that displays images of puppies on the screen. The first thing we do is we create an image provider protocol, which represents the source of our puppy images. And as you can see, it is marked as automockable, ready to be seen by SwiftyMocky. The second protocol we're going to create is a displayer, which represents our UI. So it has a display puppy function that actually displays the image on the screen, and it's marked as automockable as well. And now we move on to the actual class puppy presenter. We inject our dependencies, and we start creating the function that displays the image on screen, which simply calls the provider to get the image and places it on the screen. So really simple example that we want to showcase to give you an insight of how SwiftyMocky will help you test this class. So we jump into our puppy presenter tests. We have generated our mocks with SwiftyMocky, and immediately you can see that we have image provider mock and displayer mock available for us to use in our unit tests. So we can start by writing our first test. We want to test that the display puppy function actually updates the UI correctly. So we start by creating the puppy presenter with the dependencies injected. We'll give the puppy a name like a golden retriever and an image to be returned by the provider. And now we need to specify that the provider actually returns the image for that specific variable name. And we will do this with the given syntax in SwiftyMocky. So you need to specify the value of the name variable to be passed to your mock, and simply it will return that image only if that variable is passed correctly. So now that we have the setup, we can go ahead and call the display puppy function that we want to test. I'll wait for it to be finished. And finally, the verification side of the test, we need to verify that the UI was updated correctly. This is done with the SwiftyMocky syntax of verify. As you can see, it's really readable, really easy to understand. And our team writing this mock and this test hasn't spent time doing manual work, but just focused on what's really important for the business, for the success of our developers. So now, SwiftyMocky wouldn't be a unit testing library if it didn't provide you with debugging tools. So the first thing that can happen when you're testing is that you have a mock, but you forget to set the return value for a specific function or variable. In that case, the test will fail, and SwiftyMocky will let you know that a return value was not specified for your function. I will suggest you to use the given syntax to actually do this. The second thing you can do is forget in your production code to actually call a function. And in this case as well, the test will fail, and SwiftyMocky will let us know that we were expecting one or more invocation of our function, and we didn't get any. The third thing that can happen is the function is called, but it's actually called with the wrong parameters. In this case, the SwiftyMocky library will tell you as well what happened. So it will let you know that a call was happening. It will give you a list of closest calls recorded with their parameters. So you can check which parameters were used compared to what was expected. So now we wanted to estimate how much it would actually take our team to create mocks manually on a day-to-day work. So we thought about a best case scenario of at least 25 minutes a day per developer writing mocks manually. This is calculated by having maybe 5 minutes at minimum writing a mock manually. And let's say you want to test 5 different things, so 5 different mocks that you need to create. This is the best case scenario for us. At Conto, in the last 6 months, we calculated that we spend less than 3 minutes per developer per day generating mocks with SwiftyMocky. So this is a huge achievement for us, and we're able to stay more productive and focus on what's important. So now, you've integrated SwiftyMocky in your project. Your team is more productive because they're not spending time writing mocks manually, but your testing target starts compiling really slowly. This happened to us at Conto, and we want to show you how we approached it and how you can do the same in your team and achieve blazing fast compilation of your testing target. So let's go back for a second and talk about the SwiftyMocky generate command. As you know, by default, it outputs a Mock.generated file. This file can get really large really quickly, and in 2023 at Conto, we had 300,000 lines of code of Mock.generated. This was a huge headache for our team. It was impossible to open because Xcode would freeze, and our team was really struggling. So we had to find a way out. We started by taking a look at the Xcode build timeline, and we saw immediately that there was a huge gap. That was the Mock.generated file compilation. As you can see, there's no parallelization of work during this compilation. We're focusing our compilation onto one single thread, and we're not parallelizing the work and using all the resources at maximum. So the solution for us was only one. We had to split the Mock.generated file into multiple files, one per protocol. The results were outstanding for us. We were able to take our mocks compilation from more than 6 minutes to less than 2 minutes. We were using the CPU cores in parallel at the same time, and this was a much faster compilation for our testing target. We were able to get a 54% reduction in clean build time, a 35% reduction in iterative build time, so the second time you build a project. And finally, this was the most important for us, we were able to get a 72% reduction in build time after one protocol change. This is the most common use case for a developer writing a feature because you write one function at a time, you create one test at a time. So it was a huge boost in productivity for our team. And now we want to show you how you can do the same in your team after you've integrated SwiftyMocky. So to split the Mock.generated, there are 4 steps. We'll start by updating the mock file to output a folder instead of a single file. The second thing we're going to do is the update to the template. So we'll specify that the mock generation will happen one per each file and not only one file. We'll then use Sourcery directly to go beyond the limitations of SwiftyMocky. And finally, we need to synchronize the Xcode project with the newly created folder structure in your file system. So let's start. The first thing we do is the update to the mock file. We'll simply change the output from a single Mock.generated file into a mocks/generated folder. The second thing we do is the update to the template. So mock.swift_template by default provided by SwiftyMocky starts with a for loop, and it cycles onto an all array. The all array contains all of your protocols to be mocked. As you can see, the definition of each mock will be placed one below the other in one single file by default. What we did was really simple. We just added a Sourcery annotation inside the for loop to specify that the mock definition should be placed one file per each protocol. Third step is the Sourcery usage to go beyond the limitations of SwiftyMocky. So as you remember, the mock file is really a Sourcery configuration file. So you can go ahead and call Sourcery directly with the updated configuration. And finally, the last step, the synchronization of your Xcode project. As you well know, Xcode doesn't automatically see your file system structure, and you need to find a way to synchronize the two. You can do that with something we call Xcode GroupSync. Xcode GroupSync is an open source library created by our colleague Ruslan at Conto. It's really readable for us iOS and macOS developers because it's written in Swift and it leverages frameworks like Xcode Proj created by our friend Pedro and the Swift argument parser created by Apple. And it's really easy to set up, so you just specify the Xcode project to insert the files into, the folder that you want to synchronize with your Xcode project, and the target that those files will belong to. And the script automatically updates the project references in Xcode and the compiled sources in your build phases. So this was a huge learning opportunity for us. We're really happy to share this with you today. And you can go ahead and scan the QR code for the GitHub repository of Xcode GroupSync, or you can find also the Medium article written by Ruslan describing this process that we've just went through. And now, back to Sara.
Thank you. Actually, just to summarize a bit what we have talked today, we talked about to increase the code coverage, actually test your code and I bought 9 minutes. How to generate mocks just to speed up developer productivity, and the importance of open source library, how can scale your business, how can help the community, and also it could be like a self-improvement opportunity. So this is everything from us. Thank you, and